So today we are going to discuss about optical activity of amines. We all know that amines are those organic compounds or inorganic compounds, we can say, which are attached with 3 substituents and 1 lone pair. Just consider this is the characteristic structure of amine. This is the characteristic structure of amine because nitrogen is there. Nitrogen have a lone pair. A lone pair, if I am mentioning, it means that a pair of electrons, that is 2 electrons. A lone pair is a pair of electron, that is known as the one pair of electron, that is known as lone pair, and one lone pair contains 2 electrons. Nitrogen contains 2 electrons as a lone pair and other electrons are participating in the bond formation with 3 substituents. This is the general structure of amines. I have already explained the general structure of amines in the lectures of IUPAC. So amines are those compounds in which nitrogen having a pair of lone pair and it is connected with 3 substituents. And it is connected with 3 substituents as well. So now you have to consider a particular amine. Now I told you about the hybridization parameters as well. So according to the hybridization, how you are going to calculate the hybridization? This particular amine having a steric number that is equals to 4. We already know because we have learned about the steric number concepts in our basic classes. Steric number is equals to 4 because there are 1 lone pair and 3 bond pairs. So the steric number is equals to 4. Now consider this the structure of amine, and I am told you about the steric number because the particular structure having 1 lone pair, that is 1, and 3 sigma bonds, 1, 2 and 3. So we have 1 lone pair and 3 sigma bonds, that is equals to 4. So our steric number is equals to 4. And if I am saying our steric number is equals to 4, our steric number is equals to 4, and if our steric number is equals to 4, it means our hybridization is tetrahedral. sp3 hybridized nitrogen atom, this is sp3 hybridized nitrogen atom. This is sp3 hybridized nitrogen atom. What does this mean? It is sp3 hybridized nitrogen atom. It means that this particular amine structure is tetrahedral in nature. I have already told you about the structure of tetrahedral, that is a particular atom connected with 4 bonds. 2 bonds are in the plane, one is above the plane and other is below the plane. I have already told you about the structure of tetrahedral. 1 bond is above the plane, 1 is below the plane, and 2 bonds are in the plane. Now you have to carefully observe this because this particular lone pair is above the plane. We are mentioning this because to solve the questions in the exams, we have to make our approach easier always. So just consider this particular lone pair is above the plane. Just consider I have attached the lone pair here and hydrogen here, methyl group here, and I am going to attach the ethyl group here, that is equals to CH2 and CH3. So now consider this is the tetrahedral structure of amine. This particular center is nitrogen. Now consider that this lone pair is above the plane, is just like a pyramidal type structures. Geometry is tetrahedral but the shape is pyramidal. Geometry is tetrahedral. You have to remember this, that the geometry of amines are usually the geometry of amines are tetrahedral, but we don't know what happens if we are going to observe the quaternary structure. Then also the geometry is tetrahedral but shape is not always same. Here the shape is pyramidal type, but when we are having the quaternary amines, then the shape as well as geometry both are tetrahedral. But when we have the geometry tetrahedral and shape is pyramidal, only possible when we have a 1 lone pair of electrons. When we have 1 lone pair of electrons. Now consider the geometry is tetrahedral, but what about the concept of shape? In shape we are not considering the lone pair. In shape we are not considering the lone pairs. So you have to consider this as a pyramidal structure because here the lone pair is present, so we have to consider the shape in which we don't have to consider the lone pair. So this is the structure in which nitrogen is connected with these particular items and one is R1, R2 and R3. Just assume for the sake of convenience that is going to be R1, R2 and R3. Now consider lone pair of electrons which is present above the plane. Just consider this is a pyramidal shape type structure. Just consider nitrogen and these particulars are in the plane. Just consider this particular structure are in the plane. You have to consider that these all are in the plane, and when you're considering that this particular lone pair is above the plane, so just assume that lone pair is above the plane, nitrogen and the two substituents are in the plane, and one particular bond is below the plane. Below the plane means that the particular bond is far beyond you, because the screen is the plane that you are seeing. This is the plane in which the nitrogen R2 and R3 are coming, and the lone pair is coming towards us, and this particular R1 is coming below the screen, going far away from you. It means that this particular R1 is going far away from you, and this particular lone pair is above the plane coming towards you. It means that. So this is a pyramidal shape type structure. So you have to assume the structure of amine in environment. You have to consider to understand the stereochemistry behind the amines. So you have to consider a pyramidal shape like structure like this. You have to consider a pyramidal shape like structure like this. This is a pyramidal structure. Two are in the plane, and this is above the plane, and this is below the plane. Just like this you have to assume. Okay, so this is the structure of amine. Now just consider this particular nitrogen. This is the nitrogen, and nitrogen is usually connected with 4 atoms, 1, 2, 3 and lone pair. So it's connected in 4 different groups. It connected with 4 different groups. Why I am saying one group is lone pair, other is hydrogen, third is methyl group, fourth is ethyl group. So it will having 4 different groups. If the particular atom is connected with 4 different groups, then that particular atom is chiral in nature. Just remember the rules of stereochemistry that we have discussed in the earlier lectures. When you are going through that particular lectures, I have told you about the carbon center. When the carbon center is connected with 4 arbitrary groups, and those 4 arbitrary groups are different in nature, then that particular carbon center is optically active. So you have to consider here that if the nitrogen is connected with 4 different groups, then what happens? If the nitrogen is connected with 4 different groups, then that nitrogen can be optically active. I am not assuring you that the all nitrogen when connected with the 4 different groups are optically active. No, we have some criteria, some barriers in the optical activity of amines that we are going to learn in this particular lecture. So you have to consider the parameter that if the nitrogen is connected with 4 different groups, then they can be 4 different groups, then they can be optically active and optically inactive, but we cannot determine what the either it's optically active, inactive, just like if the 4 different groups are connected, so it are optically active. No, we cannot determine like this. We have another parameters that we have to consider. Either the groups are optically active or inactive. So we are going to consider that now. If I am saying the nitrogen is connected with 4 different groups, then that particular nitrogen is